Myself G.DHARSHINI, Assistant Professor of Geology, A.D.M.COLLEGE for Women, Autonomous NAGAPATTINAM. Let me see groundwater. So first of all, what we see is groundwater and sources of groundwater, the groundwater system and water-bearing qualities of rock, movement of groundwater, water quality and groundwater contamination, and remediation of groundwater contamination. Let me see groundwater. Groundwater is the water that exists in the four phases of and fractures in a rock and sediment beneath the earth's surface. It originates as rainfall or snow and they move through the soil into the groundwater system, where it is eventually met it be back to the surface in lakes or oceans, etc. Groundwater makes up to about 1% of water on the earth. Most of the water is contained in oceans, but groundwater makes up about 35 times the amount of water in the lakes and streams. The volume of groundwater is equivalent to a 55 meter thick layer spread out over the entire surface of the earth. It is an important resource of potable water, irrigation, and industry. Groundwater is a primary agent of chemical weathering and it is responsible for the formation of caves and sinkholes. Groundwater occurs everywhere beneath the earth's surface, but is usually restricted to depth less than about 750 meters. Sources of groundwater. Meteoritic water. It is the water derived from precipitation, rain or snow. Although the bulk of rainwater or meltwater from snow and ice reaches the sea surface through a surface flow or runoff, the considerable part of the precipitation gradually infiltrated into the ground. This infiltrated water continues its downward journey till it reaches a zone of saturation to become a part of the groundwater in the aquifer. Connate water. This is the water present in the rock right from the time of their deposition and aqueous environment. During the process of formation of sedimentary rocks in the lake or sea or river, the deposition is followed by a compaction which leads to the squeezing out of most of the water present between the segments. Sometimes, however, incomplete compaction may cause retention of some water by these routes. This is the connate water and may be encountered in sedimentary rocks like limestone, sandstone, and gravels. It is a commonly saline in nature and it is of no importance as a source of exfoliatable groundwater. Then, Jwanine water. It is also called magmatic water and it is only theoretical importance as far as water supply schemes are concerned. It is the water formed in the cracks or pores of the rock due to the condensation of the stream emanating from the hot metal masses or magmas existing below the surface of the earth. Some hot springs and geysers are clearly derived from rainwaters. Then let me see groundwater system. The groundwater resists the void spaces of rock, sediments or soil completely filling with the voids. The total voids open space in the groundwater can reside in porosity. Porosity determines the amount of water that can a rock or sediment can contain. So porosity. In sedimentary or sedimentary rocks, the porosity depends on the grain size, the shape of the grain, and the degree of the sorting and the degree of cementation. Well-rounded coarse-grained sediments usually have higher porosity than the fine-grained sediments because the grains do not fill together well. So poorly sorted sediments usually have lower porosity and because the fine-grained fragments tend to fill the open spaces. It is divided into primary porosity and secondary porosity. Primary porosity. Porosity between the grains preserved during the liquefaction process is known as primary porosity. In sedimentary rocks formed in intercalcular spaces. In igneous rocks formed due to vesicular structure. In metamorphic rocks formed due to foliation and lineation process. Then secondary porosity. Secondary porosity is a porosity that developed after the rock formation. The process such as fracturing, faulting, joining, dissolution can create a secondary porosity. In igneous rocks formed due to joints, fault, shear zones, and irregular cracks, etc. Generally, in igneous and metamorphic rocks, porosity is usually low because the minerals tend to be interwoven, leaving little free space. Highly fractured igneous rocks and metamorphic rocks, however, could have high porosity. Then, permeability. It is a measure of degree of to which the four spaces are interconnected and the size of the interconnections. Low porosity usually results in a low permeability, but high porosity does not necessarily imply to high permeability. It is possible to highly porous rock with a little or no interconnection between forces. A good example of rock with a high porosity and low permeability is a vesicular volcanic rock, where the bubbles that once contained a gas give the rock a high porosity. But since these poles are not connected to the one another, the rock has low permeability. Permeability is dependent on porosity. Coarse-grained rocks are usually more permeable than the fine-grained rocks, and the sands are more permeable than the clays. All rocks are neither capable nor suitable for holding and transmitting groundwater. The following terms should be understood clearly before discussing the water-bearing qualities of rock. So, let me see water-bearing qualities of rock. Aquifer. It is defined as a rock mass, layer or formation which is saturated with groundwater and which by its properties is capable of yielding and containing water at economical cost when tapped. The quality of an aquifer will therefore depend both on how much quality of water a rock formation can hold per unit volume and what rate it can yield water when tapped for supplies. It is storage reservoir and transmission content at the same time. Then gravels, limestone and sandstone generally form good aquifer when occurring in suitable geological conditions and geographical situations. Aquifer, a rock body or a formation which may porous enough to hold enough quantity of water, but which by its other properties does not allow an easy and quick follow throughout in a called aquifer. It is treated as a practically impermeable rock masses. Compacted clay formation are the best examples of the aquifer. Aquifer. It is an absolutely impermeable rock formation through which there is no possibility of store and movement of water. Such formation is almost free from forces and other indices. Example, compact interlocking granites and quartzites. Then aquifer. It is a less common term used to sometimes for aquifuge or aquifer that has become locally weakly due to development of partial previences called cast by because of profuge joined or rock cracks. Aquifers can be divided into two types. The one is unconfined aquifer, the another one is confined aquifers. Unconfined aquifers, the most common type of aquifer where the water table is exposed to the Earth's atmosphere through the zone of aeration. Confined aquifer, these are less common but occur when aquifer is confined between the layer of impermeable strata, water table. Rain that falls on the surface seeps down through the soil into a zone called a zone of aeration or unsaturated zone, also called a vada zone, where most of the pore spaces are filled with air. That it is penetrated deeper, eventually enters the zone where all the pore spaces and gaps are filled with water. This zone is called the saturated zone or phreatic zone. The surface below which all openings in the rocks are filled with water, the top of the saturated zone. It's called the water table. The water table occurs everywhere beneath the earth's surface. In desert regions, they are always present but rarely intersects the surface. During dry season, the depth of the water table increases. During wet season, the depth of the water table is decreases. Movement of groundwater. Groundwater is a constant motion. Although the rate at which it moves is generally slower than it would move in a stream because it must pass through the passageways between the free space in a rock. First, the groundwater moves downward due to the pull of gravity, but it can also move upward because it flows from a higher pressure areas to the lower pressure areas, as can be seen by a simple experiment illustrated below. Imagine that we have U-shaped tube filled with water. If we put pressure one side on the tube, the water level on the other side rises. Thus, the water moves from the higher pressure zone, the zone pressure zones. The same thing happens beneath the surface of the earth. Where pressure is higher beneath the hills and lower beneath the valleys. The earth's surface can be divided into areas where some of the water falling on the surface seeps into the saturated zone and other areas where water flows out the saturated zone onto the surface. Areas where water entered the saturated zone are called recharge areas. Because the saturated zone is recharged with the groundwater beneath these areas. Areas where groundwater reaches the surface, lakes, streams, springs are called discharge areas because the water is discharged from the saturated zone. Generally, recharge areas are greater than the discharge areas. The groundwater movement is slow relative in that is the surface streams because it must percolate through the pore openings and further slowly friction and electrostatic forces. For comparison, the types of rates flow as follows. Ocean current 3 km per hour. Steep river channel that flows 30 km per hour. Groundwater 0.0002 km per hour. The groundwater flow occurs in a variety of scales. Local shallow flow occurs over short time and distance, and whereas the deep long distance flow occurs over time scale of centuries. The rate at which groundwater moves through the saturated zone depending on the permeability of the rock and the hydraulic head. The hydraulic head is defined as the difference in the elevation between the 2 points of the water table. The hydraulic gradient is the hydraulic head divided by the distance between 2 points on the water table. The velocity V is the groundwater flow is given by V is equal to K H2 minus H1 divided by L, where K is a hydraulic conductivity, which is a measure of permeability of the material through which water is flowing. We multiply the expression by the area through which water is moving. So we get the discharge Q is equal to AK H2 minus H1 divided by L, which is Darcy's law. It simply states the discharge is proportional to the hydraulic gradient times the permeability. The discharge is higher if the hydraulic gradient is high or the permeability is high. Then water quality and groundwater contamination. Water quality refers to the such things as the temperature of the water, the amount of dissolved solids, the lack of toxic and biological pollutants. The water that contains a high amount of dissolved material through a action of chemical weathering can have a bitter taste and is commonly referred to as hot water. Hot water can occur if a water comes from the deep source or encounters by a cooling magma body on a transport through the groundwater system. Such hot water may be desirable for bath houses and geothermal energy, but is not usually desirable for human consumption or agricultural purposes. Most pollution of groundwater is the result of biological activity, much of it human. Among the sources of contamination are septic tanks, water tanks, gasoline tanks, biological waste products. Biological contamination can be removed from the groundwater by natural process if the aquifer has interconnection between the forces that are smaller than the microbes. For example, sanitary aquifers may act as a filter of biological contamination. Aquifer pollutants such as fertilizer and pesticides, saltwater contamination result from the exclusive research of fresh groundwater in coastal regions. Then, remediation of groundwater contamination problem. In order to begin remediation, contaminated character is first done monitoring well and all instant to assess flow of behavior. This is allowed for chemical testing to quality of the amount and the characters of contaminants. Strategies are designed to reduce the health risk. Remediation is usually quite expensive. Most strategies include removing the source of the contaminant, the pumping the groundwater out, the treating it. Sometimes the heat is pumped on the volatile and the groundwater or steam pumped in the clean out the contaminants. Newly developed technicals uses bacteria to clean groundwater process is called bioremediation. Thank you.